Okay, so we're still in this messaging topic, and indeed it's going to be the last topic that we're going to look at. And I mentioned there in the Slack message yesterday, I think, about this lab, which is a lab that you need to submit. Now, uh, I added a new section to it there, whatever, yesterday or the day before. And there will be I think at least one other section as well that will be added. I'm kind of adding these sections as we cover topics. So there is one more uh, part of this lab that I need to talk about probably next week now, maybe at this stage, or well, although I might start it today, called filtering. And when we've covered that, I will reveal that particular section of the lab. And then you'll have completed it and you can submit the lab. All in all, I think I did change the hand update for the lab. I can't remember what I changed the hand update to, but it's either next week or the week after. So just be aware because I noticed that most people had, well, I guess they had submitted their GitHub repo link, which is fine. That doesn't change, but just be aware of the fact that there is some more work that you need to do on this lab before you can consider it complete. And indeed, this lab and the topics that I've been covering since we looked at serverless, they will dominate the lab-based exam, which I'll talk about maybe a little bit more next week. Okay, so the topic that we're looking at is messaging. And maybe if I jump over to the slides. So just to kind of refresh our memory, the idea of messaging is that there are probably a couple of aspects to it, but I presented it as a way of decoupling compute components so that you don't have synchronous communication between compute components. And I talked about the downsides of that. Now, in the AWS world, when we're talking about decoupling compute components and introducing messaging as kind of intermediaries, then the two main services that we look at are SQS and SNS. There are a few others as well, like there's something called an event bridge, which we won't get to look at. So yeah, we're focusing on these two here, SQS and SNS. And again, just to remind you, with SQS we have producers and consumers. Producers add messages to an SQS queue. Consumers kind of read those messages or process those messages. Whereas with SNS, we talk about publishers and subscribers. It's just the vocabulary is slightly different. With SQS, if you remember, uh, the consumer is responsible for periodically polling SQS, asking it, do you have any messages for me? And SQS will batch those messages. So the idea of batching is a characteristic of SQS. Your consumer will receive batches of messages. And also, because the consumer is doing this kind of polling action, there's always a delay between the time that the producer writes a message to a queue and the consumer gets around to processing it. There's always going to be a delay period there. But if you're, from a design point of view, if you're happy that there will be a delay and that's not going to affect the overall characteristics of your application, then that's fine. The other aspect of SQS was when a consumer receives a batch of messages and for whatever reason it doesn't process that batch completely, either because it times out or it's found an error in a particular message and throws an exception. Either way, if it doesn't complete the processing of the batch, then SQS will kind of retry and redeliver that batch to the consumer, or put another way, the next time the consumer polls SQS, it may well receive the same batch. Now, you don't want that to go on forever, and so that's where we introduced this idea of a dead letter queue. You can set a limit in SQS, you can set a limit to how many times SQS will give a message to a consumer for processing. And if that limit is reached, then SQS will move that batch of messages into another queue, which we call the DL queue. And note that it's SQS actually does that for us. That's not something that's handled on the consumer side. That's something that you configure on the SQS side. So that was this dead letter queue idea. Okay, so there are some of the characteristics of SQS, this idea of batching, polling, and dead letter queue. With SNS, what we know about it is that when the publisher, writes a message to SNS, to an SNS topic, immediately SNS tries to deliver that message or push that message to a subscriber. It's not the subscriber, there's no polling going on here now. There's a kind of a push mechanism between SNS and the subscriber. And so once a publisher writes a message to an SNS topic, pretty much immediately SNS tries to pass that message on to the subscriber. The publisher doesn't wait for SNS to do that. All the publisher waits for is for SNS to respond saying, I received your message. Okay, publisher is out of the picture at that stage. So that's fine. SNS kind of pushes the message to the subscriber, and there's no batching involved here now. It's kind of a one pushes a message at a time. So that's kind of where we left it off. Maybe if I fast forward to roughly where we left it off the story in our slides. Well, okay, we had this fan out idea where you could have multiple subscribers. In this image, I'm showing the subscribers as being SQS queues, but we know that you can have Lambda subscribers and there can be other types of subscribers as well. And what SNS does is it delivers every message to every subscriber, unless you tell it otherwise, and the otherwise will come a little bit later on. But that's what it tries to do, push every message to every subscriber. So that's this fan out idea. And we had examples of that. That's all right. Skip over all of that stuff because we've done it before. I only talked over this slide, but it is an important slide to be aware of. You see, if I go back maybe to here, let's see. Yeah, in this sample that we looked at in a previous lecture, here we have our SNS topic and we've got two subscribers. In one case, the subscriber is a Lambda subscriber, so it's directly subscribing to the topic. Whereas in the second case, we do have a Lambda, but this Lambda is not a subscriber to the topic. It's actually a consumer to a queue, and the queue is the subscriber to my topic. And I kind of posed the question, well, when should you use a Lambda direct subscriber? And when should you use Lambda as a consumer to a queue, and the queue is a subscriber? Okay. And we kind of talked about that. And what we kind of concluded was that if the message that is being sent to the topic, in my case, it's just the CLI, but it could be anything. It could be another Lambda or some other service that's writing messages to my topic. If that message needs to be processed as quickly as possible, so it's some sort of time critical message that needs to be processed, then in that case you should the processing Lambda should be a direct subscriber to your topic. If that's not the case, if the processing of the message isn't time critical, then take this approach. Let SQS batch these messages, and eventually this Lambda will process through them. Okay. So again, I talked about that in this slide here. And then I think this is really where we left off the last day. We talked about, you see, we still have the issue now here of, okay, your publisher writes a message to an SNS topic and then the publisher is out of the picture. But what kind of guarantees do we have that SNS will actually deliver the message to your subscribers? And that's where this delivery policy and protocols kind of came in. And I talked over this image the last day, which I took directly off the documentation. And the upshot of it all really was that SNS really keeps trying and trying and trying and trying to deliver the message to the subscribing service. If it's a Lambda, for example, that's the subscriber, SNS does not deliver message directly to your Lambda functions. What it does is it tries to deliver the message to the Lambda service, and then it's up to the Lambda service to deliver the message to the Lambda function. Equally, if the subscriber is an SQSQ, then SNS tries to deliver the message to the SQS service, and it lets the SQS service take care of putting the message into the right queue. So SNS talks to other services. It doesn't talk directly to your resources, like your Lambda function or your SQSQ. But what this image here shows is that, it keeps trying, I think we said it over a period of 22 days, keeps trying to deliver the message. Now, eventually, if it still can't deliver the message after 23 days of attempting, then you can tell SNS what to do with the message. In those cases, we're not going to look at that though. Now, supposing your subscriber is a Lambda function and it's directly subscribing to your SNS topic, and SNS delivers the message to the Lambda service, and the Lambda service invokes your Lambda function, but your Lambda function, let's say, throws an exception while it's processing the message, or it times out while it's processing the message. We're kind of back to this situation now again of kind of dealing with error scenarios. Who handles an error when it occurs in this kind of asynchronous message driven kind of application design, application architecture? So SNS delivers a message to the Lambda service. The Lambda service provides it, invokes your Lambda function, and your Lambda function cannot process the message. It throws an exception while trying to process the message. What happens? What happens to the message? Because every message is critical, so it needs to be processed. Now, in that kind of scenario, what you can do is you can actually configure a DLQ linked to your Lambda function. And so what the Lambda service will do is if the Lambda function cannot process the message, keeps throwing an exception, then the Lambda service will put the message into the DLQ, which is an ordinary SQSQ, and then you may have another Lambda that's dealing with the messages in the DLQ. So what are we saying? SNS invokes a Lambda function subscriber asynchronously. That's okay. And the reason we need this DLQ is because of that asynchronous nature. SNS does not wait for the function that's okay. Yeah, like so once SNS delivers, yeah, that's probably a better explanation. Once SNS delivers the message to the Lambda service, then it doesn't care what happens after that. It's done its part of the agreement. Uh, but now we're saying, supposing the Lambda function actually throws an exception, uh, it's actually the responsibility of the Lambda service to deal with that exception that has been thrown by the Lambda function. And as I've been saying, what we can do is we can configure our Lambda function so that those faulty messages are put into an SQS queue. Yeah. So let's suppose we've got this very simple scenario. Okay, we're using the CLI for convenience as our publisher into an SNS topic. The SNS delivers the message eventually to a Lambda function, but we're actually going to configure a DLQ with this Lambda function to deal with the error scenario. And maybe there's, as I said, maybe there's another Lambda function that processing DLQ. We don't really care about this one. For this demonstration anyway. What we were wondering about is how do we connect up these two together? How do we configure this integration here? And it's pretty straightforward, really. So this is my little demo. And in the demo, what we have, is a queue, which is going to be our DLQ. Sorry, it's not, no, sorry, we've got an SNS topic. We've got a queue, which is going to be our DLQ for our Lambda. We have got our Lambda function, and this is the line here. So there's this on failure property associated with Lambda, and you can configure that. You can configure it to, sometimes you might want to configure it to trigger another Lambda. If this Lambda fails, I want to trigger another Lambda. In my case, what I want is if this Lambda fails, by failing we mean throw an exception, then I want the message to be sent to my queue, my SQS queue. So that's this on failure property. Now, I could have talked about this on failure property way back when I started talking about Lambda. It's not specifically linked to, a Lambda that's a subscriber to an SNS topic. So anyway, that's how this is how we connect up our Lambda function to a DLQ. The rest then is well, okay, this is the Lambda that's handling the messages in the DLQ. We don't really care about what it does. And the rest is just normal kind of integration, connecting up my Lambda to my SNS topic, which is what I'm doing here. And here I am just connecting up the second Lambda as the consumer of my DLQ. The Lambdas themselves, don't think they do. Sorry, no. This is the Lambda that's a subscriber to the topic. And so what I'm going to be doing is sending messages, and you can see here, it's just checking to see, does the message have an address property? If it doesn't, throw an exception. So that's how I'm going to force messages to finish up in the DLQ. This Lambda here, this is the one that deals with messages in the DLQ. But again, we don't really care about it. It just console logs. Is that all it does? Yeah, just console logs out the messages. So I've deployed this scenario, and the messages that I'm going to be sending to my SNS topic are just going to be like this. Okay. And so if we send, so I have deployed it, and what will I do? I'll send AWS SNS. So if I send this one, this should get through and be, this message should not finish up in the DLQ. And therefore, okay, let's just send that off. And if I send another message now, if I change this, I got my address, and I'll just change the email to O'Connor2. Yeah, send off that message. And if we now switch over to CloudWatch, so something is going to happen now, which we wouldn't have predicted, and I didn't mention it purposefully. So if I go into CloudWatch, wherever CloudWatch is, so we've got two lambdas now. So we should have two log streams. This log stream here is the stream for my subscriber. Let's just remind ourselves of the architecture. So it's the log stream for this lambda, the subscriber. I do a refresh to see has anything appeared on the queue one yet. No, there's a bit of a delay. That's okay. So let's look at the log stream for the subscriber. And here it is here. So if I expand this, which is the console log of the event, here's the message here. And so Dermot O'Connor, and the email is DO'Connor at wit.ie. That was fine. So that one was processed successfully. There was no exception thrown. Let's make sure of that. No, there's an end there, so that worked out fine. Then I sent a second message. So that's why we're getting another part to my log stream. So this is the message where I took out the address, and I just changed the email to DO'Connor2. Where's my message? There, message. Oh yeah, there we go. Message. There we go, sorry. There's no address, which is what we did. And the email is DO'Connor2. So that's okay. And if we scroll on further, we can see, what can we see? can see it's starting again. And let's expand this. Oh no, sorry, that's the exception. This is the exception that was thrown by the Lambda because it didn't find the address. So that's as we would expect. But there seems to be some more stuff going on. It seems to be starting all over again for a third time. And if we expand on that, I only sent 2 messages. So why is there a third invocation of my Lambda subscriber? And what is the message of the third invocation? And if we look at the message, message, it seems to be sending the second message a second time. And you know, it's going to throw the exception yet again. It's throwing the exception again. And it doesn't finish there because if I refresh, so I can tell you that what's actually happening is for the second message, which is the faulty one, the Lambda service keeps retrying to get the Lambda function to process that second message. Well, it actually only it has 3 attempts. It gives the Lambda function 3 attempts to process the faulty message. It's kind of pre-configured. I don't think you can change that configuration. It's kind of built into the Lambda service. So that's what's actually happening in our log stream. Let's just go back over that again. So this is the first message. That's okay. This is the second message. It's the first processing of the second message. This is the second processing of the second message. And this is the third processing of the second message. And I can tell you that it doesn't go any further than that. It doesn't try a 4th time and a 5th time. It gives up after 3 attempts. And it's only now, having tried 3 times to get the Lambda function to process the faulty message, it's only after the 3rd attempt that the Lambda service will actually send that message to my DLQ. And that will then trigger the other Lambda being this Lambda here. Eventually, this one will poll the queue and it will process the message. So if I go back to CloudWatch, I should now see a log stream for this Lambda. So it takes quite a while before that log stream appears because, as I was saying, this Lambda actually is given 3 attempts to process the faulty message. But let's make sure that the second Lambda does actually eventually get triggered. And there is here's the log stream for the Lambda that's a consumer of the queue. And, you know, I didn't do anything in that one other than console log the batch of messages that it received. And if we expand this, and somewhere in here is the actual message. You can kind of see it there, right? Email D. O'Connor 2. So so the DLQ mechanism is working for us, but what I didn't say when I was explaining it is this idea that the Lambda service actually, it doesn't put the faulty message into the DLQ straight away. It actually tries to give the subscriber 3 goes at processing it. Right, so that's that. That's a way of dealing with error scenarios when you've got a Lambda that is a direct subscriber of an SNS topic. Now, back to this fan out pattern, and uh, by default, your SNS service will try to deliver every message to every subscriber. But you may actually want to tweak that a little bit. You may only want certain messages to get to certain subscribers. You may have some subscribers that you want to receive all messages, but there may be some subscribers that you want to filter out certain messages that you're not interested in. And so we have this idea of filtering combined with the fan out pattern. And you can just follow the kind of, the color coding that's going on here. We've got different types of messages, and I may not have said that, but an SNS topic, you don't define a schema for the messages of an SNS topic. So that means then that an SNS topic can receive different types of messages. That's kind of the understanding. But on the subscriber side, that's where you want maybe your filtering to take place, and the filtering is performed by SNS. Like of course, well, you can do it with queues, but if you had a Lambda subscriber here, you could have some condition statements at the beginning of your Lambda function to decide what messages are relevant or not. We don't particularly like that approach though, because that means the Lambda has to execute and you're paid for that execution. If you can do the filtering before it actually reaches the subscriber, that's a more preferable approach. And you can do that with SNS. So when we're talking about filtering with this fan out pattern, there are what are called filtering policies and filtering criteria. So what kind of filtering policies are available to us? And it turns out that there are two policies. One is based on attributes of the message. Now, I haven't spoken about message attributes up to now, but you could think of message attributes as metadata associated with a message. A message typically is a set of key value pairs. It's a JSON structure with key value pairs, where the values are the actual values of the message body or the message payload. But separate from the body, you can also associate attributes to your message. And attributes as well are kind of is a JSON structure. But in this case, the key value pairs represent kind of metadata associated with the message. And you can do the filtering on the basis of those attribute values. Alternatively, and in conjunction with really, you can do the filtering on the basis of the values of the actual message body itself, of the message payload. So there are the two policies that are available to you. I think you can combine them. It's not a case of having either attribute-based filtering or message body-based filtering. You can combine them, but we will only look at them kind of being used separately. Okay, so there are the two policies and the filtering criteria then. You see, in the case of attributes or message body, they're both kind of JSON structures, and the filtering is based on the values or some of the values within those two JSON structures. And those values could either be strings or numbers. They're the only two possibilities, really. Okay, Boolean is in there, but we'll ignore that. Okay, so the values are either strings or numbers. And so you have various string filter criteria that you can define. And I'm listing them here, right? You can have an allow list filtering criteria. And in an allow list for a string, what you essentially do is specify an array of values that you are saying, if the value of a particular property, be it of the body or an attribute, if the value is equal to one of the values in this allow list, then you're allowing the message to go through and pass on to the subscriber. Alternatively, you can specify what's called a deny list. Again, a deny list is an array of string values, and the way it works is if the value of whatever part of the message that you're doing the filtering on, if the value is a string, number one, and if the value is one of the values in your deny list, then you are saying do not allow that message to go through to the subscriber. So you're either specifying values that you want SNS to pass on to the subscriber, or you're specifying values which dictate messages that should not be passed on to the subscriber. A third option is match prefix. In match prefix, you're making a declaration about the prefix value, of a particular value, be it of the body or an attribute. And there's also a match suffix. Is there a match suffix? Do I mention it? Match prefix. Yeah, match suffix. So these are the different criteria that you can use and different ways of essentially telling SNS how it should carry out its filtering. So you need to tell SNS two things. Number one, am I doing attribute-based filtering or body-based filtering? And whichever of those you're using, you've got to tell it, well, which particular attributes are you doing the filtering on, or which particular parts of the body are you doing the filtering on? And thirdly, then you've got to tell it what is the filtering criteria that you want it to apply to the particular values that you've identified from up here. And sometimes it's easier to specify an allow list, sometimes it's easier to specify a deny list. Sometimes these don't actually work. You need to specify a match prefix or a match suffix. That's if the value is a string type. If the value is a numeric type, then you've got all of these condition filtering operators kind of available to you. And the third type of filtering criteria is what's called an exist filter. Basically, you're saying if a particular property, be that a property in the attributes or a property of the actual message body itself, if that attribute exists, then allow the message to go through. And only if it exists, allow that message to go through. By implication, if the message does not have the particular attribute or the body does not have the particular property, and you've specified one of these exists filtering, then you're essentially telling it to not allow the message to go through. I guess examples hopefully make it a little bit clearer. And we'll be doing this in the lab actually. So let's supposing we've got this scenario. Oh yeah, okay. So here's my architecture again. Again, just for convenience, I'm using the CLI. Check my time. I'm using the CLI as my publisher. I've got an SNS topic and I've got two subscribers. We don't really care about this subscriber, but I'm leaving it there anyway, because just to show you that this subscriber doesn't have any filtering. So every message will finish up in this queue, which means this Lambda will process every message. Whereas this Lambda here, it's only going to process certain messages because there's actually going to be a filter defined for this subscription. And the filtering is stated here. So the Lambda subscriber, that being this guy, the Lambda subscriber should only receive messages where a user type attribute, so there's going to be a user type metadata attribute, A user type attribute is set to either student or lecture, and a source attribute uh, has to begin with the prefix Slack. Okay, so we're assuming there's going to be two uh, attributes accompanying every message: user type and source. And the user type attribute, it must have the value, the string essentially student, or the string lecture. And if it does, then potentially we're going to allow that message to go through. If it doesn't have one of those, then the message is not going to be allowed through. But in addition to that, there has to be a second attribute called source, and the value associated with that attribute has to begin with the prefix Slack. Okay, let's look at the code. And here's my stack file. Uh, that is that what I want. So I realize something now, actually. I'm looking at the wrong one. I've just realized now, sorry, that I actually have the wrong case study configured. Let me just try and recover the situation. Yeah. Actually, no, I won't try and recover it now because that's a bit of a mess up now on my part. Well, let me just try and let's forget completely about everything that I've said here. Instead, what I'm going to do is the example I'm going to have is I have an S3 bucket. Sorry, no, this just isn't going to work. Sorry, no. Uh, okay, I'm going to stop here actually, and I'm going to pick it up the next day where we will look at this case study. Yep. Okay. So I'm going to pause it there. Let me just look at the lab. Is that affecting the lab? Don't know how now I messed up on that one, but so be it. DLQ, yeah. So this is the new section in the lab, a DLQ section. It's quite short actually. Shouldn't take you long to work your way through it. But and I've talked about DLQs today, but I also talked about DLQs when we were looking at the SQS service. So this section should make sense to you. I'm assuming everybody has worked their way through all of these sections up to now. If you haven't, you certainly should get going on that. And you should finish off this section by this week, this section here. And I will have another section or two for you next week. Okay, that's it for today. I'll just pause in this case there are any questions.
Can I ask? Uh, so will we have a exam at the end?
Yeah.
Would it be in like week 12 or which week would that?
I haven't finalized it. I'm actually trying to have it on the Friday of week 12, but I cannot guarantee that. It may have to roll into week 13.
Oh, okay. Yeah.
It definitely
Yeah.
won't be any later than week 13, and it certainly won't be any earlier than week 12. I mean, this is week 10, so certainly not going to be next week. Ideally, I'd like to have it on the Friday of week 12 during the double lab hour that we normally have scheduled. That's what I'm aiming for. But if for whatever reason I can't get it scheduled for then, it will roll into week 13.
Okay. So it'll
Yeah.
be either week 12, like the Friday in week 12 or Friday in week 13.
It
Week.
won't, I'd say it won't be the Friday of week 13. That's because I mean, you see, the problem with trying to organize, trying to get a free room, a free lab room really, it's almost impossible to get a free lab room during the academic semester, week 1 to 12. But once you get to week 13, then it's very easy to get a lab room. So if it does push into week 13, I would try and have it on the Monday or Tuesday, I'd say, of week 13.
Okay.
Yeah.
All right. Thank you.
Yeah. Okay. That's fine. Nothing else? Okay. I'll talk to you whenever. Thanks. Bye-bye.